All right, so Mauricio has given you a really good sense of why we developed Q in the first place and the problem it was meant to solve. We had all these awful shell scripts that people wrote in a very ad hoc fashion for their pipelines. It was a huge mess, so we wanted a standardized way to write our pipelines that was easy to use and easy to reuse. And that's how Q came into existence. So now we're going to go over just the very basics of running Q and writing QScripts. So we're kind of here in today's talks. We'll do some advanced talks later in the afternoon on running on the farm, and then just the last talk is going to be like super advanced topics for the power users out there. But here we're just going to go over like writing your first QScript and running it and your first pipeline and that sort of thing. So we're going to cover running Unix commands, so like an arbitrary Unix command, as well as GATK tools, and also multiple GATK tools in a pipeline, so where the output of one tool becomes the input of the next tool. We're also going to go over adding arguments to a script and running the script locally in a shell. So we're not going to cover the farm yet. That'll be the next talk. And then we'll do a little bit on debugging QScripts and how to test that your script works. So a QScript is quite simply a script that you run through Q. Mauricio mentioned it's written in Scala, but you shouldn't have to worry about that. Your task as QScript author basically involves doing a bunch of assignment statements, so like x equals y. That's literally all the programming you need to know. There is a little more, but we're going to give you that, and you can just kind of copy it as a boilerplate to use in your own scripts. In general, you have one QScript per pipeline, so per workflow. And in your script, you define what tools you want to use, as well as what are the inputs and outputs of each tool. So basically, you're describing your pipeline from start to finish. And here's a kind of example. You start with a BAM file, and then you run it through the realigner target creator, which is a GATK walker you learned about yesterday, to produce a set of intervals, and then you feed the intervals into the indel realigner and also the original BAM file into the indel realigner to produce the realigned BAM file. So that would be a very simple pipeline. And here's the basic structure of a QScript. At the top, you always have to import this QScript class, which is provided for you. It's packaged with Q. So just copy that line verbatim. And then the script you write is going to extend the QScript class. So if you're a programmer, you may be familiar with the concept of extending a class. If you're not, basically, you're just saying that your script is a QScript by doing this. You're just marking it as a QScript. And then the name of your script goes right there, right after the word class. And then all the action happens in this script method here in the center. So you can have more complicated scripts that have like multiple methods. You can get as fancy as you like, but you don't need to. The minimal QScript just has this one method called script. And inside that method, what you do is you just add the tools you want to use. So for each tool you want to run in your pipeline, you call a method called add, and you pass in the tool. So we're using the word command line function here. Command line function is just Q's way of saying a command to be run. So it can be a Unix command, it can be a GATK walker, it can be like a SAM tools command. You have lots of different, you have a lot of flexibility, and you can write your own as well, which is an advanced topic that will be covered at the end of the day, I believe. So we're going to start off by doing a hello world example. For those who don't know, this is kind of the canonical way to start like a computer science textbook, introduce a new feature or a new program. We're just going to write a script that outputs the text hello world. That's all it's going to do. And here is the whole script. It's very similar to the template you just saw. The only difference is the name has changed. The name is now hello world. And in the call to add, we're actually adding in an actual command line function. And so the command we want to run is the Unix command echo hello world, which will print the text hello world out to the terminal. And to do that in Q, you just define a new command line function whose command line is echo hello world. And that's how you would run like an arbitrary command. Usually you don't actually have to do this because Q comes packaged with a bunch of built-in command line functions for GATK walkers and also for some like SAM tools and Picard commands as well. So you only have to do this generally if you want to run like a custom command. Okay, so we've gone over that. Oh, absolutely.
So on your command line function, let's say you want to run a more complex command line function like an awk command with
Yeah.
single quotes and double quotes and stuff like that. How would you manage that?
You can do it. You just put all your messy Unix stuff in this string here, and it will run. You may. You may have to backslash certain characters, yeah. Single quote, I think you'd be okay. If you had a double quote, for sure you would. All right, and here's what it looks like if we actually run Hello World. So the command line to run it is just what Mauricio showed you at the end of his talk. So you'd say java-jar q-q.jar, and then the script to run is hello world.scala, and then we're actually going to run it. So you append the run argument at the end. And if you don't have that argument, it won't actually run it. So you do need that. And then you get a bunch of output. It shows you the version of Q. And the versions generally correspond to the GATK versions. They're kind of synced up with the GATK version. So when we release a new version of the GATK, we release a new version of Q as well. So that Q will always be up to date with its command line functions for the GATK tools. And then it kind of echoes back the arguments you use to run it. And then it actually runs it. So it says, I added one function, because there was only one command line function in our script. So we're only running one thing. And then it does a bunch of work, and it starts it, and then it finishes it pretty much immediately. And it says, I wrote the output to hello-world1.out. And I think on the next slide we can see that. So that's just the text hello world. You can see it has some statistics on like how your jobs are doing. That's more significant when you have like hundreds of jobs rather than just one. You can see the number of like pending, running, the number that failed, and the number that are done. And you also get something called a job report. For running on the shell, this isn't too important, but when you start running on the farm, this is actually very, very useful. You can see the start and end time of each job. You can see the hosts, so you can kind of pinpoint problem hosts on the farm. And you also get that in PDF form, so you can see a bunch of like R plots showing how your jobs did on the farm. But obviously, in this case, it's not terribly useful because we're just running locally in the shell. So as I kind of hinted at, Q comes pre-packaged with a bunch of built-in command line functions, so you don't typically have to write your own. To use the ones for the GATK, you have to add this extra import statement at the top. You import the Q extensions for the GATK. And this underscore at the end there just means all of them. I want all of them. And then once you do that, you can use all of the GATK walkers directly in your QScript by just creating a new instance of the walker. So if you want to count loci, for example, you create a new count loci and store it in a variable. And it's as simple as that. And then you add it. So if you just do it this way, if you just say val count loci is new count loci, add count loci, you're not setting any of the walker arguments, though, which you almost always want to do that because the default values are often empty. So you typically have to fill in the arguments for each walker. And to do that, you probably want to go to the documentation on the GATK website. We have some very nice automatically updated documentation, so it's always current. And if you go to this URL, you'll see for each walker, there's a page with the arguments and the type of the argument and a description and so on. And there's also a page for the engine, which is actually really important because some of the most commonly used arguments are actually engine arguments, which means they're shared by all the walkers in the GATK. So for example, reference sequence, which you may know better as -r, is an engine argument. Like all walkers have a reference sequence argument. So when you go to this page, you want to be sure to check the page for the engine first, I would say, and then go to the page for your specific tool that you want to run. But basically, the procedure is you look at the name of the argument, the long name, not the short name. So I said reference sequence is also known as -r. You would want to use the long name in your Scala script. So you get the long name, and then you literally just assign to it. So you say count loci.reference sequence is, and then your FASTA file. And same with input file and output file, or out rather. Now with input file, it's a little different because you notice these are just equal signs, right? These are just simple assignment statements. And then for input file, we have this kind of weird looking Scala operator. So what this is the list append operator. And all you need to know about this, I mean, it seems bad, but I swear this is like the worst thing you have to deal with when writing a QScript. This is it right there, the worst thing. So it's not that bad. Basically, if you see in the documentation that the type of an argument is a list, that means it's the kind of argument you can specify multiple times in the command line. So you can have multiple input files for a walker. You can say -i first.bam, -i second.bam. And because you can have this argument multiple times on the command line, its type is a list. And whenever the argument's type is a list, you have to remember to use this operator to assign to it instead of the equal sign. So it's a little bit of a pain, but that's really the worst thing you have to deal with, Scala-wise, when writing QScripts. And the other thing I'll note here is that for now, we're kind of hard-coding our argument values. So if you ran this script, you would always use exactly this FASTA file. You would always use exactly this BAM file, and so on. And that's not terribly useful. You typically want to allow the user of your script to specify what is the FASTA file, what is the BAM file. And that's what we're going to get to in a second, I believe. So what this slide is showing is this QScript here, where we create a new count loci and then fill in the reference sequence and so on, is equivalent to this GATK command down there, where you say -t count loci and then those same arguments, -f reference sequence, and your FASTA file, and so on. So it literally maps directly to your GATK command line. So it's very, very easy to convert a GATK command line that you may already have into a QScript. And you may be saying that this is actually worse than this command line because it's twice as much text, but once you start running multiple tools, the usefulness of the QScript will become obvious. So this is adding arguments. I mentioned this hard coding is not usually what you want to do. You want to allow the user of your script to specify the files to be used. And doing that is actually really easy. So at the top of your QScript, before your script method, you can define a bunch of arguments just as variables, basically. And the only trick is you have to annotate them as arguments. So most arguments are annotated as @argument. So before the actual variable, you have just @argument. And then some documentation on the argument. If you want a short name for it, you can have that. And then at the end, whether it's required or not. So if you don't say otherwise, the argument is assumed to be required. So this argument here, the -r argument, is required because we haven't said otherwise. Whereas this one for the filter names is not required because we said it wasn't. And you typically want to initialize these variables to either underscore or nil. So you use underscore if it's a single value and nil if it's a list. And those will be filled in for you by Q if the user specifies the argument. So they have to specify the -r argument. That's a required argument. So that guy will get filled in because the user will get an error if they don't specify the -r argument. But this one will remain nil if the user didn't specify that argument. So you can test in your script to determine whether the user provided any filter names when they ran the script. And you should use input and output for input and output files to your script. And argument for everything else. This is actually not terribly important. If you screw this up, it's not a big deal. Q won't really care that much. It's good for documentation purposes, though. Someone reading your script would want to know what are the input files to your script. So for that reason, we recommend doing this, but it's not crucial if you screw that up. Okay. And to run a QScript that takes arguments, you just append the arguments after the script name. So we're running myscript.scala, and we're passing in the -r argument and the FASTA file, and then two -i's, because the -i argument, which we define here, is a list. So that means I can specify it multiple times. So this script can take multiple BAM files on the command line. And to do that, you just list the BAMs one after the other on the command line. Here's a gotcha. This is one of the first things you typically run into when you're using Q as a new user. So Q internally will keep track of which parts of your pipeline have finished. So let's say your pipeline, one of the command line functions in it outputs this VCF, variant calls.vcf. When that guy is finished, when it's been completely written, Q is going to create this little hidden file here, .variantcalls.vcf.done, and it's hidden because it starts with a dot, so those are hidden in Unix. And this just tells Q this file is done. So if you run the script a second time, it's not going to try to create this file again. It's going to skip the command line function that creates this file because it knows that that file is done. And this is actually really handy because if your pipeline crashes halfway through, you can pick up where you left off. You don't have to rerun the parts that already succeeded, which is a really good feature. But sometimes you do want to start over. You want to say, I want to rerun it from the beginning and just blow away everything that's already there. And Q lets you do that by through this argument, start from scratch. So if you want to do that, you just add start from scratch to your command, and Q will delete all these hidden files and just start over from the beginning of your pipeline. And here's an example of what happens if you try to run a script that has already been run and you're not using start from scratch. So the hello world out file has already been written, so Q knows that it's done because it has that little hidden done file telling it that it's finished. So if you try to run hello world a second time, it's just gonna add the function and then it's gonna say, oh, it's done. It's immediately done. I don't have any work to do, which can be a little confusing. It confused me when I first ran Q. So if you see that happen, you just have to remember start from scratch if you really want to redo it. So we're going to go a little bit into debugging, nothing sophisticated. Basically, the main way of debugging QScripts is to do a dry run, and that's real easy to do. You just leave off the -run argument, and Q will show you what it would do, but it won't actually do anything. So it will show you all the actual commands it will run and the order in which it will run them, but it won't actually write any files or dispatch any jobs to the farm or anything. And you can actually see the full command line that it's going to run. So the full Java command line for each walker or each tool will be shown to you. And it's always a good idea to do this before you run a pipeline for real, just to make sure that everything looks right. And it will tell you if there are any errors when you do your dry run, like missing arguments to walkers, that sort of thing. And if you've previously run the pipeline and there are done files for it, you won't see those jobs in your dry run. So because Q would skip them in a real run, so they won't show up in a dry run either. All right, so far we've just done single tools, adding one command line function and running a script with it. So let's get into multiple tools. It's pretty straightforward. You add another tool after the first tool. So if you want count bases in addition to count loci, you create a new count bases and add it, and potentially configure its arguments as well. There's also kind of a shortcut for adding multiple walkers. So instead of saying add count loci, add count bases, you can add them both in one line, which is a kind of a nice convenience. And it's this is kind of a technical detail, but it is important to know. So typically, at the very top of your QScript, you define an alias called QScript, and that's just done using this line right there. So just copy that line verbatim. And that lets you access any variables you define up here. So this would be your command line arguments, as well as any other variables that you want to use throughout the script. Using that name, QScripts. You can say QScript.reference file, QScript.bam file, and so on. Now, it's not always necessary to have this. Like this script, I believe, would work without this alias. Like you could just say reference file here instead of QScript.reference file. But there are some situations in Scala where you do need to do this. So our philosophy is we don't ever want to have to think about what those cases are. So we pretty much always have this alias in our script, so we don't have to think about, oh, do I need to use it or not? I just always use it when you're accessing your variables up there. There's also a nice little Scala feature called a trait. Basically, what we use this for in Q is you're often in a situation where you have multiple walkers and they share a common set of arguments, like the reference sequence, maybe the input BAM file, maybe the intervals, or maybe something like the memory limit, right? Something is the same across multiple walkers. And what a trait lets you do is it lets you set the values for those arguments once, and then reuse them using a nice little one-line syntax for each walker. So if you want these two walkers, count loci and count bases, to both have this reference FAFSA and this BAM input file, you can just say, define a trait with those values, and then say, I want a new count loci with the common arguments, and I want a new count bases with the common arguments. So it's just to save you from having to type out like count loci dot reference sequence, count bases dot reference sequence over and over again. All right, but this is not a real pipeline, though, of course. You're just running two walkers. I mean, they're not connected in any way. Count bases is not using the output file of count loci. So it's not a real pipeline. It's just running two tools independently. But if you want a pipeline, it's pretty much the same thing. The only difference is you have to think about what are the inputs and outputs to each tool. So say you had this pipeline. You're starting with a BAM file, and you're going to run it through the UG to produce a VCF, and then you want to run that VCF through variant filtration to produce a set of filtered variants. So how would you do that? Well, or specifically, how would you tell Q that variant filtration needs to wait for the unified genotyper to finish, right? And the answer is you don't need to do anything. Q will figure it out for you. Q is going to notice that the output file of the unified genotyper is the same as the input file for variant filtration. So it will be smart enough to know that variant filtration has to get run after the unified genotyper. And it will wait for the unified genotyper jobs to finish before starting up the variant filtration jobs. And this is that directed graph that Mauricio was talking about briefly. So this is kind of the internal data structure that Q builds up in order to figure out the dependencies in your pipeline, like what needs to get run first and second and so on. So here's how that looks in code. The unified genotyper's output file is going to be this file called unfilter.vcf. And then the input file to variant filtration is the unified genotyper's output file. So because you, yeah, oh, sorry, I thought I saw a hand. So because the output file for the first tool is the input file for the second tool, Q knows to run this second. Now, the order in which you define these in the code is not actually significant. You could take this whole block that's defining the variant filtration tool and move it to the top, and Q would still know that variant filtration needs to get run after unified genotyper. So it does not make a difference like what order you add things or anything like that. Q will figure it out for you. And so when you get into pipeline, you have to be aware of what is considered an input and an output to each tool. So certain arguments to walkers are considered as inputs and outputs, and others are not. And you can find out which those are by going, again, into the documentation. It will be very clearly labeled which are inputs, which are outputs, and which are neither of the above, right? So Q is going to build its dependency graph using only the inputs and outputs. If there's an argument that's not labeled as an input or output, it's not going to affect the order of in which the tools are run. And another thing, again, just to reiterate, many of the commonly used inputs are engine arguments, so you need to go to the page for the GATK engine rather than the page for your tool to see them. All right, so we've done enough now to be able to build up a more realistic pipeline, I think. So here's what we're going to write. We're going to start with some BAM data, some reads, run it through the unified genotyper to produce a set of unfiltered variants. And then our pipeline is kind of going to branch. So one branch of the pipeline is going to run variant-eval directly on the unfiltered variants. And variant-eval is, I don't know if you saw this yesterday, but it's a tool that kind of gives you statistics about your variants. So like number of SNPs, number of indels, that sort of thing. So like summary statistics. So that's going to be one half of the pipeline. And that's going to produce a variant-eval report on the unfiltered variants. And then there'll be an optional second branch of the pipeline. And that is going to run variant filtration on the variants to filter the variants according to user-supplied filters. And then it's going to run variant-eval on the filtered variants to produce an evaluation of those. And this is going to be an optional branch because it's only going to get run if the user provides certain arguments to the QScript. Okay. So here's a kind of a high-level overview of the script we're going to write. This should all look pretty familiar to you based on what you've seen so far. We're going to have some import statements at the top. We're going to define the class. We're going to extend the QScripts, give it a name, and so on. We'll have this little alias here, just so we don't have to deal with Scala stuff. Then we'll define the arguments to the script and common arguments in a trait. So the arguments that are shared across walkers will be defined there. Then we'll have our script method, where we'll define the tools to be run. We'll assign the inputs and outputs, so the arguments that were not in the trait, in other words. Then we'll add the functions, and then we'll have like a conditional statement to only add that second branch of the pipeline if the user of our script specified certain arguments. All right, so here's that top piece. You have the two import statements that you usually need when scripting GATK tools, the QScript class and the GATK Q extensions. And then here's our class definition. We extend QScript. We're going to be called the example unified genotyper. And then we have our QScript alias at the top, which is going to let us access the variables that we define here. And here are the arguments to our script. So we take several arguments. Some are required, some are not. So the required ones are at the top here. This is the reference FASTA file. So we've given that the name R. So the user of our script will say -R on the command line. And then we have one or more, oh no, just one, because it's not a list. So just one BAM file, which is also a required argument. And again, you don't actually have to say required equals true. If you leave this out, the argument is assumed to be required. And then a bunch of optional arguments. So we can have an interval list, which is going to be the -L argument. And then a bunch of filter names and filter expressions, which are also optional. So these arguments are going to determine whether that second piece of the pipeline with variant filtration gets run. If the user doesn't specify any filter names or filter expressions, we're not going to run that second piece, because we can't run variant filtration if we don't have any filters to use, obviously. So, okay, so that was our arguments to the script. Now we have the trait for the arguments that are shared across walkers. We're defining the reference sequence is always going to be, for every tool, whatever the user specified here in the -R argument. So QScript.reference file. The intervals for each walker, if the user specified the intervals, we're going to use what the user specified, so this argument here. But if the user didn't, if QScript.intervals, if this variable is still null, we won't use any intervals. So we'll do a complete traversal of the file. And then we're also going to say the memory limit for all the tools is going to be 2 gigabytes. A little low, but I don't know. For this, it should be fine. And then here's the start of our script method. We're defining first the 4 tools we want to run. So we're going to be running the unified genotyper. And notice these are all with common arguments. So we're using this trait so that we don't have to set the reference sequence, the intervals, and the memory limit for each of these tools over and over. So we're going to be using the UG. And then variant filtration we might use. And then 2 variant evals. One is for the unfiltered and one is for the filtered. So we need 2 different ones because they're going to be having different input files. So even though it's the same tool, we need 2 different instances of that tool in our script. And now we set up the inputs and outputs. So the unified genotyper's input file is going to be the BAM file that was passed into the QScript. So that's this argument here, the -i argument that we defined at the top of our script. And notice we use colon plus equals because input file, if you look it up in the docs, is a list. The walkers can take multiple input files, so we have to use that weird assignments operator. And then the output file is going to be, here we call into a kind of utility method, which is going to swap the extension. We're going to take the name of the BAM file that the user gave us and change the extension from BAM to unfiltered.vcf. And this is just a convenience method. It comes with the QScript class, so you get it for free. You can use it in any QScript. And it's often the case that you want to do this. You want to keep the same base name for your files, but just change the extension at the end repeatedly as you move down your pipeline. And then here's the variant eval for the unfiltered variants. So that's this piece of the pipeline. So the unified genotyper is producing this unfiltered VCF. And then the variant eval on the unfiltered variant is taking that as input, right? And the output will be, and we call swap extension again to change the extension from VCF to eval, because what you get out of variant eval is a report, so the extension is typically .eval for those. And that's this file over here. And that's this piece of the pipeline. And then here's the second piece of the pipeline, the part we might possibly not run. So we set up a variant filtration with the input equal to the unified genotyper's output file, so this file here. And how do you know that the input for variant filtration is an argument called variant? Well, you look it up in the docs. The docs will tell you, oh, the input for variant filtration is named variant. The output file is going to be this filtered VCF, so that's right there. And that's going to go into another variant eval for the filtered variants. And again, you would have to look up in the docs to see, okay, the input for variant eval is an argument called eval. It's a list, so I need to use colon plus equals instead of just equals. And then the output file will be the filtered eval file over there. But this might not get run, so that it gets set up, like the inputs and outputs are defined, but it might not actually get run. And that's the next piece. We decide what is actually going to get run. So we're always going to run the unified genotyper and variant eval on the unfiltered variants, right? This piece of the pipeline. Always going to run that. But we only run the second piece. So we only call add to add variant filtration and variant eval on the filtered variants if there were filter names. So if the user actually gave us filter names here. And if they didn't, we'll just skip that part. Okay, so here's what it looks like if we run this script without specifying any filters. So we're just specifying, here's the name of the script, the reference FASTA, the input BAM, and -run to actually run it. It will only add two functions. So that would be the unified genotyper and the variant eval on the unfiltered variants. And you can see the actual commands that it runs here. So here's the UG, and here's variant eval on the unfiltered variants. And it runs them, and it says, okay, I finished. I finished 2 jobs. So that we did only this part of the pipeline in that case. Now here's an example of running the second branch of the pipeline. And we're assuming we're kind of doing these back to back. So Q has finished this half of the pipeline. And Q knows it's finished because it writes those hidden done files. So when we run this a second time with filter expressions, it's not going to rerun this part of the pipeline because it knows that these files over here are done. So it's only going to run this new branch of the pipeline that now becomes available because we're specifying filters. So you can see on our command line we added a -filter for the filter name and then a filter expression. So the QD must be greater than 1. So we're only going to get variants where the QD is greater than 1. And this time it's going to run only the pieces that it did not run previously. So it's going to run the variant filtration tool and then variant eval on the output of variant filtration. But it does not rerun it does not rerun the other part of the pipeline that it ran previous. And you can see it starts off immediately with 2 tasks are already done because it knows that those are done. Okay. All right. Oh, like that. So that's Q101. I hope it wasn't too much of a brain dump for you. We'll take some questions now before we get into the more advanced topics of running on the farm and defining custom command line functions and so on. So anything you guys want to ask about? Yep.
So the unified untyper output, it looked like the output file was switched from .bam to unfiltered.tcf.
Yeah.
So if the input to unified untyper is a list, and you have multiple BAM files, what does the unfiltered DCF get called?
Okay, so it's true that the unified genotyper does take multiple BAM files. It has the ability to handle multiple BAM files, but our script does not have the ability to take multiple BAM files because when we define the argument for our BAM file, we didn't make it a list. So we're saying in this pipeline, you can only have one BAM file. Any other questions? What if it was a list? Okay, you would just what's the question? If it was a list, what? If it what?
I think the idea is how do you implement the swap text to make sure that all the files.
Oh, I see. I see. Yes. In that case, you have to iterate over the list, or you don't have to use swapx in that case. I mean, there may be an alternate version of swapx that takes a list. I'm not sure. But if there isn't, you would have to do it manually. You'd have like a loop to do it.
We can ask that question again in the advanced topic.
Yeah, that's an advanced topic, I think. So stay for the last talk if you want to learn more about that stuff. Anything else?